Good day, everyone. As you all know, my name is Mr. Fabiodun. So, I want to continue from where we stopped in our last class. So, in our last class, we ventured into some aspects of projectile motion. Before I move on to the topic proper, so let me just do a recap of what we do in our previous class. So, in our previous class, we did horizontal projectile and motion under gravity, and I expect that or I assume the topic is clear to all of you. So I told you something last week, which is that if you have any issue with any question you come across, so feel free to send those questions to me. But it's just very funny that I didn't see any of you, like send any questions. So let me just assume that you understand the topic. So our next topic of discussion, or what we ventured into in our last class, before we had to round it up, was on projectile motion, and I've explained some things to you about the topic. Now, when you talk of projectile motion, I told you that projectile motion is a motion that describes what we call the parabolic movement of an object. So that means the motion of an object in this form. So that means it is that you have what we call the xy plane. So this is the y plane, this is the x plane. So you have what we call the xy plane. So now when it is that you throw an object from the horizontal ground and the object lands, okay? So the object lands on the same horizontal level from where it was projected. So that part of motion is what we call a parabola, or what we call motion of trajectory. So we said that a projectile motion describes the parabolic motion of an object. So unlike the other one that we did, which is the horizontal projectile, you project an object from a height. So the object lands not on the same horizontal plane from where it was projected. It lands on the horizontal floor. You project an object from a particular height, it lands on the horizontal floor. So that one is the horizontal projectile, and unlike what we call motion under gravity. But for this one, it has to do with projecting an object from the horizontal ground and it landing on the same horizontal level from where it was projected. So that form of motion is what we call projectile motion. And I told you that that object, in quotes, that object that undergoes that form of motion is called a projectile. So that means an object that undergoes projectile motion is called a projectile. And I told you that a projectile is an object. The way I define it for you is an object in which, when it is launched into space, is allowed to move freely by itself under the influence of what we call acceleration due to gravity and air resistance. So I made mention of what we call, or let me say I explained what we call air resistance to you in our last class. I told you that air resistance has to do with the frictional force that exists in air. So though the frictional force that exists in fluid generally is called a viscous force. Liquid and gas is a fluid. But the one that we specify majorly for air is called air resistance. And I laid emphasis on if it's that you throw an object, let's say two different objects or two different masses from an height. So it is expected that they're supposed to land at the same time. But the reason why it is not so, or the reason why they don't land at the same time, is because the object with the lighter mass has the effect of air resistance on it more than the object that is of greater mass. That is the reason why the object that is of greater mass will land before the one of a lighter mass. So I wanted to know that. So I told you that we have different application of projectile. So it is used in launching what we call the mechanically propelled missiles. And I gave you examples of such missiles, like a ballistic missiles. So we also use it in what we call sports. We use it in sports, like a long jumper. So a long jumper, high jumper, thrown, shot put, and some other sports like that, or a fired ball. So that's one of the applications. I will also apply it in what we call warfare. So which has to do with maybe you throwing a bomb, a fired arrow, and some other things like that. So those are some of the applications of projectile. So projectile is an object. When you launch it into space, it is allowed to move freely by itself under the influence of acceleration due to gravity G and air resistance. So the projectile motion is a motion that describes the parabolic movement of a projectile, or when you say of an object. So the motion that forms this part is what we call a projectile motion. Now when we talk of projectile motion, a projectile motion consists of what we call two independent motions. So the first is what we call the constant horizontal motion. the constant horizontal motion, which we are still going to represent diagrammatically. The constant horizontal motion, that's the first. And the second is what we call the what? A vertical motion of free fall due to gravity. So those are the two independent motions that the projectile motion exhibits, or that the projectile motion has. So what we call what? The constant horizontal motion, which is a part, or I would say what we call the what? The x-axis, and what we call what? The vertical motion of free fall due to gravity. So the vertical motion, which can what? Which can come before what? It lands. So that means what? The effect of what? The gravitational force is taking effect on what? On one of the what? Of the motion that what the projectile motion has. So the vertical motion of free fall due to gravity, that is one what? That has the effect of what? The gravitational force. Or what we say what? It has what we call what? The effect of the gravitational force on it. Why the constant horizontal motion is just what? The motion from what? From the point of projection to the point where the projectile hits the projection plane. So those are the two independent motions that a projectile motion consists of or contains. So these two constant, two independent motions is what we are going to use to explain what we call the terms that we use in projectile. Don't forget, we ventured into what we call we are about to start discussing what we call the terms we use in projectile last week. So I told you that we have different terms that we use in projectile. So the first is what we call, let me start with the initial velocity of the object. You throw an object, the initial velocity of the object, it makes an angle with the horizontal, an angle theta with the horizontal. So we have what we call the time taken to reach the maximum height, which is represented as what we call small letter t. We have what we call the maximum height attained or reached by the object. So the maximum height from from the horizontal level ground. So we have what we call the range. So the range, which is the horizontal distance covered. That is the constant horizontal motion. The horizontal distance covered by the projectile, and we have what we call the time of flight. That is the total time taken by the projectile to hit the projection plane. Now, the initial velocity represented using u, the initial velocity of the object, are conversant with that. The angle of projection theta, the angle with which the initial velocity makes with the horizontal. So we also have what we call the horizontal and the vertical velocities. The horizontal is represented using what we call ux, and the vertical represented using what we call uy. So the vertical component of the motion, or the vertical velocity, and what we call the horizontal velocity. So these are all the terms that we use in what we call a projectile motion. The first is what we call let's start with from scratch. We have what we call the horizontal velocity ux. You know, x plane is horizontal, because you know much about what we call the cardinal axis. Plus y, negative y, plus x, and negative x. So if you want to consider what we call the positive plane of the xy axis. So the x-axis is horizontal, while the vertical is the y-axis. Now, ux, we know u is the initial velocity. When I talk of x, that means the horizontal velocity. So uy is the vertical velocity. Our small letter t is the time taken to reach the maximum height. Our h max, or what we call the h, is called the maximum height attained by the projectile, or you call it the maximum height reached. You also have what we call the range. That is the horizontal distance covered by the projectile. And you also have what we call the capital letter T, which is called the time of flight. So I'm not going to relate all these terms that we're using in projectile to these two independent motions that a projectile motion contains. Now, the first, I'm going to start from here. We have what we call the vertical motion of free fall due to gravity. So look at now, the vertical motion of free fall due to gravity. When you talk about the vertical motion of free fall due to gravity, it contains the parameter, the time taken to reach the maximum height, the maximum height attained, the time of flight, and the vertical velocity. So those are the terms that the vertical motion of free fall contains, due to gravity contains. So it implies that we are now going to what? Relate all these things to what? To the vertical motion of what? Of free fall due to gravity. If you recall, I told you that we have 4 equations of motion. The first being S is equal to V plus U all over 2 times T. The second being V equals what? U plus AT. The third one is what? V squared is equal to U squared plus 2AS. And the last is what? S is equal to UT plus 1 over 2 AT squared. So these are all the 4 equations of motion. So that means we are going to what? Relate all these 4 equations of motion to the what? To all these parameters that we just mentioned. We are going to start with the what? With this, which is what? Uy, which is what we call the what? The vertical velocity. So our Uy, the first parameter, okay. Okay. So the first parameter, our Uy, which is called the what? The vertical velocity. So the vertical velocity. Now the vertical velocity, as you all know, is the what? Is the vertical component of the what? Of the motion. Now look at the motion. Okay, clean everything. Okay, look at the motion now. This is the initial velocity. This is the what? Horizontal velocity, and this is the vertical velocity. It implies that invariably this can form out what we call the what? A triangle. Look at what I'm trying to say. This is the initial velocity, the hypotenuse U. This is the what? Horizontal velocity, our ux, and this can be what? Can be tagged in this form too. So that means it's coming this way too. If you want to what? Like normalize it, you can say what? It can also be normalized in this form. So which is also the same as that. So this is what? The vertical velocity Uy. So this is the angle between what? The initial velocity makes with the what? With the horizontal. You can see that this has formed a triangle. This is our Uy. Uy is the what? Opposite, because it's what? It is the side facing the what? The given angle, theta. This is our U, which is what? The side facing the what? The right angle, that is angle 90, because this is the right angle triangle. So the longest side of the what? Of the triangle is the side facing the what? Angle 90 degree, which is called the what? The hypotenuse. So hypotenuse H. The one facing the given angle is called the what? Opposite, while the other one is called the what? The adjacent. So this has eventually formed a triangle. So that means we can make something out of this. What am I trying to say? So let's go to a data page so that we can what? Analyze. Okay. Now look at, this is the triangle we formed. This is our U, this is our theta, this is our Uy, and this is our what? Ux. Now we know from our SOHCAHTOA, that is the what? The trigonometric ratios. Sine, cosine, and what? And tangent. You know that what? Our sine theta, which is called SO, is given as what? Opposites all over hypotenuse. That's why I call it SO, OH. S, the first alphabet, OH, SO. So for easy memorization, that is why we use what? SOHCAHTOA. So for what? For sine. So you remove the first alphabet, opposite over hypotenuse, you're now slotting the what? The first alphabet for opposite, the first alphabet for what? Hypotenuse. To what? To make that so. S-O-H, so. So opposite over hypotenuse. You all know that our opposite is this, like I gave you in the other slides. This is our what? Adjacent, and this is our what? Hypotenuse. Now the implies our what? Our opposite being what? Being the angle facing the given angle is given as what? As Uy all over. What's our hypotenuse? Our hypotenuse is what? Is U. So it implies that what? Our sine theta is equal to what? Uy all over U. Now if you cross multiply, it implies that what? Our Uy will now be equal to what? U sine theta. So that means the expression used in calculating the what? The vertical velocity is expressed as what? U sine theta. So that is that. Now I want us to move on to the what? To the one of the what's it called? The horizontal velocity, so that we can just merge it up to the what? To the other formulas. Because I want to strictly what? Like emphasize on the what? On the differences in terms of what? Of the two independent motion that we have what in projectile motion. But for the fact that we just have no choice than to what than to like prove the formula or the expression for the horizontal velocity, that means I will need to do that. Now our vertical velocity is the first one. So the expression for vertical velocity uy is given as what? U sine theta. And unit for what? Velocity is what? Meters per second. So now let's move on to the next one. The second one, which is called what? Horizontal velocity ux. Horizontal velocity. So the unit of what? Anywhere you see velocity, you know it is the meters per second. But the horizontal velocity ux. Now from that drive, what's it called? Our triangle that I gave you in this previous slide. Okay. From this our triangle, you can also get our what? Our cosine. That is car. That's what we call it. Car adjacent over hypotenuse. So we know that our what? Our cos theta is equal to what? Adjacent all over hypotenuse. So from our what's it called? Our triangle, we know that the adjacent is what? Is our ux. So it implies that our cos theta will now give us what? Ux all over the hypotenuse is what? The hypotenuse is u. So all over u. So it implies that what? Our ux will now give us what? U cos theta. So this is the expression for calculating the what? The horizontal velocity. So it is this velocity that we now use what? As a yardstick to what? To prove all other expressions as terms used in projectile. Now don't forget, I gave you the four equations of motion. I gave you the four equations of motion. But for this topic, what's called that we are discussing, we are going to make use of what? Of the third to the fourth. That means we are going to exempt the first because it is not useful as regards what we are talking about, what we are discussing. So we are just going to emphasize on the on the second, third, and fourth equation of motion. As regards the As regards the The vertical motion of free fall due to gravity. Don't forget. As regards Vertical motion of free fall due to gravity. Now the first one. We know that the first equation of motion is expressed as is expressed as V is equal to U plus AT. Now don't forget, I told you that when you are talking about what we call the vertical velocity. Vertical velocity, it implies that at the maximum height, the final velocity is 0. So that means in this case now, our final velocity will be equal to what? 0 is equal to, don't forget to, when you try an object up is what I'm talking of, not dropping an object from here to. When you try, because normally you know the object will go up. So for the fact that it will go up, it implies that the maximum velocity at the maximum height, as I taught you earlier in horizontal projectile will be equal to 0. Now we're not talking about what? An expression for what? For vertical velocity. Vertical motion is what we're talking of now. It implies that our u will now become what? Will now become uy. Plus, now don't forget, I told you acceleration, not linear, I'm not talking of linear acceleration, I'm talking about what we call acceleration due to gravity. It implies that there will be the acceleration will now be represented using what we call our g, which is the acceleration due to gravity. And in this case now, the object is going up. It implies that the object is acting against the Earth's gravitational force, which makes our A to be equal to negative g. I believe that is clear. Don't forget, throwing an object up implies that the velocity at the maximum height is 0, and our initial velocity at the maximum height also is what I said. Our velocity at the maximum height will be 0, and our A will be equal to negative g because the object is acting against the Earth's gravitational force times our t. So it implies that our uy minus gt, because our plus times minus is minus gt will be equal to 0. So you can make our let's say our t is the formula because we want to get the expression for the time taken to reach the maximum height. It implies that our t will be equal to uy all over g. Now if you recall from our first expression for the vertical velocity, I told you that our uy is given as u sine theta. So it implies that our t will now be equal to u sine theta, which is uy all over g. So this is the expression used to in calculating the time taken to reach the maximum height, which is this. So the time taken to reach the maximum height. So we define that the time taken to reach the maximum height as the time taken by the projectile to reach the maximum vertical distance from the plane of projection. Let me come again. We define the time taken to reach the maximum height as as the time taken by the projectile to reach the maximum vertical distance as measured from the what? Horizontal projectile plane, or we say horizontal projection plane. So the unit of what? Of t is in what? Is in seconds. The unit is in what? Seconds. We know time. The unit of mean time is what? Is in seconds. That is the time taken to reach maximum height. Now let's now move to the second term, which is what? Sorry, the fourth term. I believe this is the fourth term. So we've done our what? Our uy. We've done our what? Our ux. So we've done our what? Okay, I believe we started from here. Okay, let's just start it here. So we've done our what? Our t. The time taken to reach what? The maximum height. Now the fourth term that we're going to talk about is what called the what? The time of flight t. So the time of flight, look at now, from this motion now, we say the what? This one is the time taken to what? To reach the maximum vertical distance and measure from what? From the horizontal projection plane. It implies that what? Half of the time is what? Is the time taken to reach maximum height. So that's our what? Our time of flight is the total time for what? For completion of the what? Of the objects to drop at what? At the same horizontal level from where it was projected. It implies that what? This time of flight is what? Will twice what? The time taken to reach maximum height. But we are still going to use what? One of the equations of motion to what? To get the expression for what? For the time taken to reach the maximum height. So we say that what? It is twice. It is twice the time taken to reach the maximum height. So we can simply be expressed as what? 2 times our u sine theta all over g. So which eventually makes our time of flight to be equal to what? 2u sine theta all over g. So this is the expression for what? For calculating the time of flight. I'm still going to prove another expression for you. Now, don't forget, the time of flight is the what? Is the total time taken by the what? Projectile to reach what? The same level or the same horizontal what? Level from where it was projected. Its unit is also in what? Is also in what? Seconds. But let me now refer to what? One of the equations of motion to what? To prove the what? The time of flight proper. To prove the expression for the time of flight proper. Don't forget that our expression for what? Okay, we've used this. This is out of it. So we've not used this, we've not used this. So that means we can use what? One of the two to what? To get the expression for time of flight. And that would be what? The fourth equation. S is equal to ut plus 1 over 2 at squared. Our S, if you recall, our S is equal to what? Ut plus 1 over 2 at squared. Now, for the time of flight now. Don't forget, we said that our what? Our T, capital letter T, don't mix them. Our capital letter T is what? Is the time of flight. While our small letter T is what? Is the time taken to reach the what? To reach the maximum height. So in this case now, okay, let me refer back to the other equations if I'm not mixing them up. Okay. Now, in this case now, you want to obtain what we call what? The time taken to reach maximum, the time of flight. So that means, don't forget, our time of flight is represented using what we call what? Capital letter T. So it implies that you can just what? Slot in, instead of using small letter T, so that you won't mistake it for what? For the time taken to reach the maximum height. You just what? Slot in your what? Your capital letter T in this case now. So it implies that what? Our S is equal to U capital letter T plus 1 over 2 at squared. Now don't forget, that's talking about what we call what? The vertical motion of free fall due to gravity. So it implies that what? Some things will change. Our u won't be ordinary u, our u will be what? U sine theta, what we call the uy, because we're talking about what? Vertical velocity. Our a will become the what? The acceleration to the gravity. And it will just be the normal plus g to the what? Negative g, because what? The object is acting against. Don't forget, I told you, it's acting against the what? The Earth's gravitational force. So it implies that in this case now, our S will now be equal to what? Uyt plus 1 over 2 minus g t squared. So minus g what? T squared. So now look at now, in this case now, our S, don't forget, our S will be what? S again, it will become the height. But in this case now, you are not talking of what? You are not talking of a height at the what? At a particular point. If it's talking of the height in the real sense for what? For the time taken to reach the maximum height, they still have some what? Some things in common. But in this case now, you are not talking of what? The time to land. So that means there is no height what? Attributed to this. It implies that what? Our S will now become what? 0. because there's no height attributed to what? To the time of flight. Because I'm talking of what we call what? The time taken to reach what? Horizontal ground. Don't forget, I'm talking about what? Vertical motion of free fall due to gravity. But in this case now, that means our height will not what? Apply to the time of flight. So it implies that what? Our 0 will now be equal to what? Uyt plus, okay, plus and minus is minus 1/2 gt squared. So you can take one of them to the other side. So you say our what? Our Uyt will now give us what? 1/2 gt squared. So one of the t can cancel. So it implies that what? Our uy will now be equal to what? 1/2 gt. So if you cross multiply, it implies that what? Our 2uy will now give us what? Gt. So don't forget that our what? Our uy, okay. Now don't forget that our what? Our uy is giving us what? U sine theta. So it implies that what? Our gt will now give us what? 2u sine theta. So if you take g to the other side of the equation, it implies that what? Our t will now give us what? 2u sine theta all over g, which is the same as what? As the previous one that what? That we obtained. So this one is just a direct one. Twice the time taken to reach maximum height. But in this case now, we have to use what? One of the equations of motion to what? To obtain the time of flight proper, going through all that, doing all this to get our what? Our 2u sine theta over g, sorry, which is the same as what? As the other one. So I just want to know that what? We use all those equations of motion to what? To express all those parameters or the terms that we use in what? In projectile motion. So now let's move on to the next one. Okay, you can still make do with this space. So this is what? For what? Our time taken to reach maximum height. So let's move on to the next one, which is called what? The maximum height attained. Okay, I think this is the fifth one, okay? The H maximum. So the maximum height attained. We define that one as what? As the maximum vertical distance. Don't forget the distance is what we're talking about now. Height. Maximum vertical distance as measured from what? Horizontal projection plane. So if you refer to the what? To the third equation of motion. Don't forget that the third equation of motion is expressed as what? As v squared is equal to u squared plus 2as. So to obtain the maximum height in this case now, it implies that what? It is that you fit in all those expressions that has to do with what? A vertical motion of free fall due to gravity. It implies that what? First, our s will become the what? The h maximum. And now, at the maximum height, our velocity will be equal to what? 0. That is, our v will be equal to 0. And don't forget, the object is acting against the earth's gravitational force, so our a will become what? Negative g. And our u, don't forget, we're talking about what? Vertical. So that's our what? Our u will now become what? uy. So if you set all those parameters, it implies that our v being equal to 0 all squared will now give us what? Our u. Don't forget, our u will now be the what? The vertical velocity. So that will be uy all squared plus 2. Now, don't forget, our a will become what? Negative g, because it's actually against the earth's gravitational force. And our what? Our s becomes what? Our h maximum, which is what we want to solve for. It implies that in this case now, our 0 will now give us what? Uy all squared minus, because our plus and minus is minus, that will be minus 2gh maximum. Eventually, our what? Our uy all squared will now give us what? 2gh maximum. Now don't forget, our uy is given as what? As u sine theta. So if you substitute that into the what? Given expression, it implies that what? Our u sine theta all squared will now be equal to what? 2gh maximum. So if you divide through by what? By 2g, because we want to obtain our what? Our h maximum. So that means our what? Our h maximum will now be equal to, now if you expand this now, the square affects u is a separate entity, sin theta is what? Is a separate entity on its own. So that means what? You can just what? Take that what? That square separately, which can give us what? U squared, which is for u. Don't forget there's an invisible multiplication that's what? That's connecting u and sin theta. So that will be u squared. Sin theta will take its own square. So that will be what? Sin squared theta. You can say sin theta all squared all over 2g. So this is the expression for what? For calculating what? The maximum height attained by the what? By the projectile. So these that are proven for you, starting with what? The time taken to reach maximum height, the time of flight, the maximum height reach. All those are what? Are separate independent motion, which is attributed to what? The vertical motion of free fall due to gravity. The maximum height attained, the time of flight, the time taken to reach the maximum height. All those are attributed to the what? To the vertical motion of free fall due to the gravity for one of the independent what? Motion of what? Projectile motion. So now let's now move on to what? To the last, which is called the what? The range. So that range is the only what? Is only, let me say, horizontal, constant horizontal motion that we have what? In all of the terms that we use in what? In projectile motion. Now, to get our range, don't forget that our, okay, let's use this. Our velocity, okay, the sixth term, our range, represented as what we call capital R. So our velocity is expressed as what? As distance over time. And don't forget that what? We express the what? We express the range as what? As distance taken by the what? By the projectile to what? To reach the what? Maximum. Okay. So we define the projectile as what? As the maximum horizontal distance. Look at the way I put it. Maximum horizontal distance covered by what? Covered by the projectile. So that means distance, the horizontal distance. Don't forget, the constant horizontal motion is what we are now what? Talking of now. So the horizontal distance in this case will not be what? Will not be our range. So that means our distance in that formula that I gave you, velocity distance over time what? That distance will represent the what? Our range, which is what? Horizontal distance. Our velocity will represent what we call the what? The horizontal velocity in this case, not the vertical velocity, because the horizontal velocity is attributed to what we call the what? The range. So that means in this case now, okay. So that means in this case now, our velocity will now be what? The horizontal velocity ux. Don't forget that I have to prove that what? Horizontal velocity for you because we have to what? We have to prove it the way it comes in the what? In the graph. So our ux will now be equal to what? Our distance, that is horizontal distance range, all over our time t. And this time, in this case, will now be the time of flight. Because don't forget, the time of flight can go pari passu with the what? With the range. Because we are talking about what? The time taken by the projectile to reach the same level from where it was projected, not the time taken to reach the maximum height. So in this case, now our time of flight can be attributed to the range. Because I don't know the total time covered by the what? By the object. So let me just quickly round up. So that means in this case now, our range R will now give us what? Ux times our time of flight. We all know our ux will be what? The horizontal velocity, which is u cos theta. So that means our range will now give us what? U cos theta times, if you recall, our time of flight is expressed as what? 2u sin theta all over g. So if you multiply them together, so it implies that what? Our range will now give us u squared 2 sin theta cos theta all over g. So all over g. But from our what's called study of trigonometry, our 2 sin theta cos theta is given as what? Sin 2 theta. How do we get that? If you say what? Sin 2 theta. 2 theta can be broken down into what? Into 2. Theta plus theta. That gives us what? Sin theta plus theta. So that means in this case, this one represents A, this one represents B. I know that our sin A plus B is given as sin A cos B plus cos A sin B. So A and B doesn't change in this case now. So that will just give us what? Sin theta cos theta plus cos theta sin theta. So that means in this case now, cos comes first. It can also come second. It's just like we say 1 times 2. 1 times 2 is the same as what? As 2 times 1. So anyone can come first. So that means you can bring this sign to the front. So which will eventually give us what? Sin theta cos theta plus sin theta cos theta. So that eventually gives us what? 2 sin theta cos theta. So that means our 2 sin theta cos theta is given as what? As sin 2 theta. So that means our range R will now give us what? U squared sin 2 theta all over G. So that's the expression for the range. So now let's move on to the last one, which is what we call the maximum range. Now don't forget that in our last class I told you that what? For a long jumper to cover a maximum horizontal distance, it implies that what? Its angle of projection, that is the angle theta, that is the angle with which the initial velocity makes with the horizontal must be equal to what? 45 degrees. But I won't use that concept. I'll just prove the 45 degree for you. So it implies that for you to have a maximum range, so the trigonometric expression here must disappear for you to have a maximum range. It implies that what? For you to have a maximum range, that's for you to cover what? A maximum horizontal distance. So our R maximum must be equal to what? U squared all over G. So, you know, that sine 2 theta has become what? 1. So it implies that for you to have the maximum range, our what? Sine 2 theta must be equal to what? 1. Because don't forget, it's just like we multiply 1 with this U squared. So you multiply it with 1 to see what? U squared. So for you to have the maximum range, that means the trigonometric expression, these two sine 2 theta will disappear. So in that case now, it implies that what? Our sine 2 theta will now be equal to what? 1. So how do we now get the angle? Don't forget, our 2 theta, or from our trigonometry, our 2 theta will now give us arc sine of 1. Arc sine of what? Of 1. Because we take this side to the other side, it becomes what? Arc sine. So that's our what? Our 2 theta will now be equal to what? Our arc sine of 1 is what? Is 90. So 90 degree, you can press a calculator, you get that. So our theta will now give us what? 90 degree all over 2, which will give us what? 45 degree. So that is for you to have a what? A maximum range. The angle with which what? That theta, that is the angle with which the projectile must make with what? Horizontal. Must be equal to what? 45 degree for you to have what? A maximum horizontal distance covered. So that is why you will see some what? Some projectile graphs. Some, okay? Some, the what's called the horizontal distance. Some will be like this. Some. You understand? So it implies that what? For you to have this maximum one, for you to have the maximum horizontal distance. So that's our what? Our angle with which the initial velocity must be equal to what? Horizontal must be equal to what? 45 degree. So I want us to round up here. So in our next class, we are going to do what? Discuss the what? The last aspect of projectile motion, which has to do what we call equation of trajectory. That equation of trajectory has to do what? The equation that we used as, let me say, the equation of first principle to what? To solve for what? Any question on what? In projectile motion. So we'll continue our next class. Thank you very much.